Hey, good morning. Today we're going to look at section 4.5, factoring of special cases. So before I start actually working backwards, I'm going to work forwards and we're going to use FOIL to expand these to see if we can determine any sort of pattern. So using FOIL first, outside, inside, last, I would have x squared plus 2x plus 2x plus 4. That would equal x squared plus 4x plus 4. Okay, same thing here, FOIL, first, outside, inside, last, x squared plus 3x plus 9, which equals x squared plus 6x plus 9. Here, the difference is I have negatives, so it's going to be x squared minus 4x plus 16. So it's going to be x squared minus 8x plus 16. And this is going to be x squared minus 5x plus 25. So that's going to equal x squared minus 10x plus 5. So what I'd like to talk about now is there a pattern that we're seeing? Well, you notice when these are exactly the same, so I'm squaring, I'm taking the same term or the same bracket multiplied exactly by itself. So technically what I'm looking at, I could write this as x plus 2 squared. I could write this as x plus 3, everything inside the bracket squared. This would be x minus 4 squared, and this would be x minus 5 squared. So when I'm looking at squaring binomials, you'll see really quickly that these two inside terms are always exactly the same. And they're going to be because you had x times 2 and then 2 times x. So the outside and inside are exactly the same. So you always have twice the value of that outside term multiplied by itself. You always have 2 times that value, right? 2x times 2 is 4x. 3x times 2 is 6x. Negative 4x times 2 is negative 8x. And negative 5 is negative 10. So that's the first pattern that we see. You double the value of the first variable and the last variable in all of the cases. So I can predict what this inside term is going to be simply by looking at my binomial. And then the last thing that you would notice is that 2 times 2 is 4. This is 2 squared. 3 times 3 is 9. Negative 4 times negative 4 is positive 16. And negative 5 times negative 5, oops, there's a mistake. It should be positive 25, sorry, is positive 25. So if I give you, so now let's say I give you, I'm trying to find the black pen. If I give you this, x plus 6 squared, you should almost be able to predict that it's going to be the first term squared, the last term squared, and 2 times the middle term. So 6 times x is 6x, so that should be 12x. Let's just check and see if that's right. I have x plus 6 times x plus 6. If I use FOIL, that equals x squared plus 6x plus 6x plus 36, which does in fact equal x squared plus 12x plus 36. So if you can't remember how to factor a binomial squared, you can just do it long form, FOIL, and you'll still get the right answer. But it's kind of important to recognize the pattern. Again, if I just had this, if I had x plus 10 squared, you'd say first term squared, last term squared, plus 2 times the middle term, right? So that would be the correct way. Now let's just do 2 quick examples. Using a negative number, first term squared, last term squared, and 2 times the middle, so that would be 18x. No matter whether you had a positive or a negative, you'll always end up with a positive term at the end because a positive number squared is positive and a negative number squared is positive. And let's do one more. Let's do x minus 1 squared. First term squared, last term squared, and 2 times the inside term, okay? So I've got our equal signs in there. Okay, so that is one of the first things we're going to look at for today. What we're actually going to do today is I'm going to give you the expanded form and I'm going to ask you to factor it and put the brackets back in. Okay, so we can now see that in general, right? If you have a plus b squared, this is going to be a squared b squared plus 2ab. If you have a minus b squared, that's going to be a squared plus b squared minus 2ab. And so then the last thing that we have to look at is what happens if you have a plus b times a minus b. Okay, so for that example, we're going to go over here. Let's look at x minus 2 times x plus 2. Let's use FOIL. First, outside, inside, last. I have x squared plus 2x minus 2x minus 4. And you can see quite quickly that you're going to have plus 2x and minus 2x, so the middle term disappears, and what you're left with is x squared minus 4. Okay, let's try another example. X plus 7, x minus 7. So I have x squared minus 7x plus 7x minus 49, plus 7x minus 7x cancels out, so I'm left with x squared minus 49. So the pattern when you have a plus b times a minus b is square the first, square the second, but remember that you have a negative times a positive, and you just ignore the inside terms. This is a special case where you have the difference of squares. If you take a look at that. If you were to work backwards, which is what we're going to do when we actually look at examples from the textbook, this is the difference of squares. So now if I had you looking at a binomial and asking you to factor it, first thing you'd say is, can I pull a common factor? No, you can't. And you'd say, well, I can't use decomposition because I only have 2 terms. But then you'd say, that's right, this is a square and this is a square. Not that I'm saying you should do it like this, but in your head, what you're thinking of, I can write this as x squared minus 2 squared, right? And then I would remember from our previous example that that is the same as x minus 2, x plus 2. Because these, when I multiply them out with FOIL, let's do that again in slow motion, x squared minus 2x plus 2x minus 4, because those are the same terms, one's positive, one's negative, they cancel each other out. So whenever you see a binomial, remember up to this point, we've been looking at things like 3x squared plus 3x plus 12. That's a trinomial, 3 terms. If you see a binomial, so x squared minus 25, and you think that you can't go anywhere with it, you have to just give yourself a quick check and say, is that a perfect square minus a perfect square? Remember, by perfect squares, what I'm talking about is 1 squared equals 1, 2 squared equals 4, 3 squared equals 9. So I'm looking at these numbers, 16, 25, 36, 49, what was that, 7, 8, 64, 81, 100, I'm losing track of where I am, 121 and 144, right? So you're looking at all of the numbers that are multiplied by themselves. So if I look at this and I'd say, well, I can't go any further, you'd be like, this is the special case where I actually have a binomial and it's something squared minus something squared. If in your head you need to rewrite it as something squared minus something squared, that's fine. You'll do a few of them and then you won't have to do it. And then you just say, well, that's fine. That's x minus 5, x plus 5, okay? And again, it doesn't matter whether you say that or this, because a times b is the same as b times a. So that's when you see a binomial, that's a perfect square minus a perfect square. That's how you get the answer. Remember, you could not do it for this. This is not going to work. There is no way that you can do that. And I think a lot of times people get so used to difference of squares, they'll be like, oh, well, that's x plus 2 squared, right? Because you'd be like, well, that's a perfect square and that's a perfect square and that's a plus, I'll put a plus in there. But look at what happens when you expand that. When you expand x plus 2 times x plus 2, you get x squared plus 2x plus 2x plus 4, right? So you're getting the x squared and the 4, but because you don't have opposite signs in there, you're going to get a positive 4x and you're not actually going to get back to what you started with. 4x squared, please factor this. So 4x squared plus 12x plus 9. I look at that and that is a little bit messy. However, I can look at this and I'd say, well, you know, 4x squared is the same as 2x, quantity in brackets, plus 12x plus 3 squared. Remember, I'm always trying to get back to, is this a plus b times a plus b to make a squared plus 2ab plus b squared? And if I look at that, I'd be like, I could kind of rewrite this as something squared plus something squared and see whether this value inside equals 2 times the value of the outside. Now, I hope that's making sense. I recognize that this is something squared. I recognize that this is something squared. So if I'm going back to my general, here are the 2 squared things. Does this inside value equal the equivalent of 2 times the outside terms? Well, let's see. I'm looking at 3 times 2x equals 6x. And if I take all of that and I multiply it by 2, it equals 12x. So yes, that does work. That is 2 times the outside term squared. So without doing too much work, I can say, well, you know, I have rewritten it as something squared plus 2 times the outside plus something squared. So now what I do is I'm going to write this like this, 2x plus 3 squared. Okay, so I've factored that. I've used the fact that I've looked at the pattern that we established before to see that this does actually follow that same pattern. So these are a little bit harder, and it does take lots of practice to get there. Here's another example that they have, 25x squared minus 40x plus 16. So first of all, I try to pull out a common factor. I could do this using decomposition. I could look for 2 numbers which multiply to 25 times 16 and add to negative 40. But right away, because I'm talking about special cases, I look at this and I say, well, this is a perfect square. 25x squared is the same as 5x squared. And 16 is the same as 4 squared. Okay, so then I have this and I say, is this term equal to 2 times this times that? And I see that that's 20, it is. That's 20 times 2, which is 40. That means that I can rewrite this 5x, 4, and I'm going to put a negative in there. I mean, technically it's 5x minus 4 times 5x minus 4, but I'm just going to skip a step and write it like that. Okay, so again, I'm looking at that pattern. I have something squared at the beginning, something squared at the end, and I just check, does that middle term equal, that's going to be a positive, does that middle term equal 2 times these things multiplied together? Okay, that should be, yeah, that should be a minus in there. There we go. That's the problem. Oh, should have done that minus in there because minus 4 squared is 16. Okay, so I should be a little bit more careful with that, but I'll do another example of that. So again, I notice that this is squared, this is squared. If I write it as something squared, now I already know that this is negative, so in my head, because I'm going back to this, a minus b times a minus b equals a squared minus 2ab plus b squared, because that middle term is negative. I'm already predicting that I have to have a negative 4 inside that bracket. Okay, if I have x squared minus 1, I look at this example and I'd say, okay, it is not a trinomial. It's not a plus b times a plus b or a minus b times a minus b. This is a binomial, and I think that I can't do anything with it, but when I look at it, I see that it's something squared minus something squared. This is a difference of squared. So I can kind of write this as x squared minus 1 squared, and if it's a perfect square, x minus 1, x plus 1, and I'm done. Page 230, 3, 5, 6, 7, 10, 11, and 14.